هاي يا جماعة. بجد خلاص أخيرا ده آخر فيديو هعمله ريكوردينج. أنا يا جماعة قاعدة بريكورد برضو للجريد 12 too, so I'm not just recording for you guys. فأخيرا آخر فيديو، بكرة هشوفكم. ردي بجد وحشتوني، يعني أنا عارفة إن أنا بغلس عليكم وأنتوا بتغلسوا عليا، بس still يعني وحشتوني يعني. ف I can't wait to see you tomorrow. Well, I hope you've been having a nice week, a slightly more relaxed week لأن أنا عارفة إنه for a lot of you last week was quite stressful. But I hope you are having a nice week this week. Um, طيب. I was told إنه quite a few of you struggled with dilution and the dilution calculations that were in the observation. كمان I noticed إنه only 17 people submitted the form. وده بالنسبة لي حاجة غريبة لأنه you cannot get a grade unless you submit the form. I need to submit your answers into the form علشان to get a grade in the observation. Please make sure you are doing so. Um, فأنا دلوقتي I want to start by solving a couple of questions from the observation. ثانية I'll pull it up. Oh, here يا جماعة. طيب. I'm gonna share my screen. Share solutions chemistry. We're almost done with the curriculum. I can't even believe it. بجد. يعني أصلا we're at slide 15. The whole deck is 41 slides. Imagine we could be done like this week. Not this week, but like early next week. Before Christmas break, which is kind of insane. Okay. So the first question is saying the food industry uses calcium chloride to make processed foods such as pickles. Taste saltier without adding sodium chloride. يعني تخيلوا إنه البيكل، الخيار مخلل كل اسمه ايه كان اسمها ايه الكلمة يا جماعة؟ حد يفكرني مع اني مش سامعاكم. اه، اسمها ترشي. ايوه، كل الترشي is not made using salt, not made using table salt. Fun fact of the day, it's made using calcium chloride. um فالسؤال بيقول what is the amount concentration of 750 milliliter sample of calcium chloride solution that contains 1.5 moles of calcium chloride. طيب, by the way, and I asked إنه in those questions you write your steps ليه؟ لأنه هي answers مكتوبة قدامنا يعني. answers are there to just help you verify your answer. لكن I need to see your steps. Anytime I'm given a question where I know the concentration and the volume of one sample, this question's asking me to just calculate concentration. Remember our triangle? Sorry, initially I thought it's a dilution question. So NCV. So then if I want to solve question one, what am I trying to solve for? What is the question asking me about? It's asking about the amount concentration. So this means that it's asking about C. If it's asking about C, then I need to do N divided by V, the number of moles divided by the volume. And if you remember from the exam, we had said that volume is always in liters. So I cannot input milliliters into this equation, but what I could do is I could convert the 750 milliliters into liters and start solving. So it's going to be 1.5 moles divided by 0.75. Right, what will that be equal to? Let's check. Let's check. So 1.5 divided by 0.75, that's equal to 2. So then the concentration of This is going to be 2. And remember, the unit for concentration is either big M or moles per liter. And moles per liter is kind of obvious, right? Because in the numerator, we added 1.5 moles, right? In the denominator, we added 0.75 liters. Now, someone might tell me again, Miss, هي مش 0.750? Does it matter? It's a trailing zero. دي zero في الآخر in a decimal. لما تبقى zero في الآخر في decimal, it doesn't matter. Okay? Alrighty. Now then I won't do this the second one, but the second one, you're given 63 grams. And the question's asking you about concentration. So I need to remember, okay, in order to calculate concentration, I need to do moles divided by liters, but the question is giving me grams. So then I need to convert grams to moles, which is dividing by molar mass, and then divide that by liters. Okay? So it's pretty much the same concept. It's just you're starting with grams instead of starting with moles. I also want to do a dilution question. So I'll take maybe question 1. Question 1 بيقول what is the final concentration when 4.5 liters of 3 moles per liter car battery acid is diluted to 20 liters. So anytime I have a question where I'm diluting something, where I'm adding a volume to something, this is when we use the N1C1 equals N2, sorry, N1V1 equals N2V2. No, C1V1 equals C2V2. You guys know what time it is right now? It is 1 a.m. So my brain is like barely functioning right now. Not even 1 a.m., it's like 2 a.m. because it's 1:50. Anyway, so C1V1 equals C2V2. That's my equation. Okay, anytime I'm given like one solution and I'm being told it gets diluted, anytime I am being given one solution or one volume added to another volume, this is what we do. You do C1V1 equals C2V2. And now it's just a matter of plugging in numbers. So C is concentration, and make sure you are always labeling what's solution number 1 and what's solution number 2. So in this case, I would label this as solution number 1. It doesn't matter which one is which, but they have to go together. If they're talking about the same thing, they have to go together. So the first one is the concentrated solution. The second one, the 20 liters, is for the diluted solution. So then you're going to have 20 by itself. And what am I solving for? I'm actually solving for C2. And then for C1, I've got 3. For liters, I've got 4.5. So it's going to be 3 times 4.5. And now it's just a matter of isolating for C2. Okay, so I'll just solve for it. It's going to be 3 times 4.5 divided by 20. So that's going to be 0.675. What is my unit going to be? Mangoes, apples, oranges? What is it going to be? It's going to be moles per liter. It's a concentration. So it'll either be moles per liter, which is the same thing as writing big M. So feel free to write either or. Multiple people asked me during the exam, oh, miss, what's big M? What's capital letter M? Okay, the second question is pretty much the same idea, except that you are starting with milliliters over here, so you just gotta convert milliliters to liters. And the third one is also pretty much the same, but it's asking us about volume. But it's still using C1V1 equals C2V2, and you label this is gonna be solution number 1, this is gonna be solution number 2, and then you put the numbers together and you solve. If you still have any pending questions, keep them until I come. But otherwise, this should be clear right now, and we should be ready to move on to the next concept. Okay, so I will change the slide and I'll bring in your beloved solubility table. By the way, remember when I told you that we are going to learn solubility in an upcoming unit, but then I ended up teaching it to you in the types of reactions unit? Well, this was the unit that I was talking about. This is the unit where solubility is really important. So again, just a quick refresher in a solubility table, the top part of the table, the top part of the table is where I have ions that are naturally very soluble, but when they are paired with any of the exceptions, they end up being insoluble. They end up being solids in solution. They end up precipitating. All three words are the same thing. Insoluble, forming solids in the solution. All of them are the same word. So, nitrate, for instance, it doesn't have any exceptions. So, nitrate, no matter what, it will dissolve in solution. You will not be able to precipitate something that has nitrate. Okay? The halides. So remember, chlorine and other halides. Lots of people tripped on that in the exam when we did this. So chlorine and other halides, this is still referring to the fluorine, to the bromine, to the iodine. They are the other halides. So for instance, copper iodide would still not be soluble. Even though it's not chlorine, it's a halide. So please be careful about that because during the exam last time, the number of people that asked me about this is huge when we had that quiz about types of reactions. Okay, now on the other hand, the bottom section of this table are stuff that are naturally insoluble. So these are stuff that are naturally insoluble, but then, sorry, they are naturally, yes, insoluble, but then when they are added with any of the exceptions, they end up becoming soluble. For instance, carbonate naturally does not dissolve in water. But the moment that you add any group 1 ions, so that's group 1 on the periodic table, the first column, or you add NH3 to CO3 2 minus, you end up with a soluble compound that's going to dissolve in water. But otherwise, if it just contains carbonate, like if I had, let's say, copper carbonate, that's insoluble. If I had iron carbonate, that's insoluble. And remember, this is what we did in our experiment. We ended up forming copper carbonate. That's how I designed the experiment because I knew that carbonate with anything other than group 1 or NH4 would be insoluble. Now, the PO4 3 minus is also the same case. So is the hydroxide. The hydroxide is normally insoluble unless it's dissolved with group 1 ions or calcium, barium, and strontium. But if we have, for instance, iron hydroxide, that's insoluble. Again, نعيد تاني إنه اللي فوق عادة أهو حتى مكتوب أهو بيبقى very soluble، لكن لما بيتحط مع الحاجات دي بيبقى insoluble. اللي تحت أو حتى مكتوب solid هنا بيبقى عادة insoluble، يعني ما it doesn't dissolve، بيبقى عادة in a solid state لحد ما يبقى paired بأي حاجة من الحاجات دي. If it got paired with any of that stuff, it's like magic. It just starts dissolving. Okay? طيب. I'm quickly gonna go through like a couple of questions about this for the sake of review. But you guys have periodic tables in front of you, right? There is a solubility table at the back of the periodic table. Or I could go back and if you want to take a quick picture of this table, and then we could use it as we solve. Alrighty. So the first question is, which of the following compounds is soluble in water? You got AgCl, you've got lead sulfate, you've got sodium nitrate, and you've got barium sulfate. What do you think? Take a moment, discuss this amongst yourselves, and then decide on a unanimous answer, and then I will respond to you. Alrighty. So it's gonna be the NaNO3 because remember I just mentioned that NO3, no matter what it is with, it will always be soluble in water. Let's go back. Let's go back and check. So the question is saying multiple options, like AgCl, for instance. I will look, okay, Cl is right here. Cl is naturally very soluble, but I'm gonna ask myself, is Ag one of its exceptions? Yes, Ag is one of its exceptions. So then Ag silver will not be soluble. Okay. Now, the other one was nitrate, sodium nitrate. And remember, nitrates, they are always soluble. There are no exceptions, none. So they are always soluble. So we can go ahead and choose that option. Okay. Time. Which of the following combinations would form a precipitate? And I want you to do the full chemical equation in the first question on your form. So in the first question on your form, so I'm going to give you some time to open it up and to prepare your laptop for it. But the first question, I want you to go ahead and write the full chemical equation for all four options. So for A, B, C, and D, write the full chemical equation, and I want you to check, will the products have a precipitate according to the solubility table? Again, this is all review, so we already did all of this before. So I will give you like 5 minutes. I'll give you 5 minutes. Obviously, I won't sit here and wait for 5 minutes, but you've got 5 minutes to prepare your laptop, to open up your Google form, and then to prepare your notebook, to prepare your pen. If you don't have your notebook out already, which is like such a shame if you don't, um, and then I want you to spend 10 minutes doing all four equations and then deciding which one of them forms a precipitate. And one thing I want you to remember is anytime I'm forming a new product, what do we do, guys? أي مرة بعمل فيها حاجة product جديد, what do I do? I crisscross. Okay, so in this case, you will crisscross when you form the two new products. All right, so you've got 10 minutes. Make sure, so in the first like few minutes, you're going to be prepping your laptop. You're going to be opening up the form. You're going to be opening up your notes. You're going to get a pen or a pencil, like prep yourself to solve the question. And then for the next 10 minutes, you are going to be doing every single choice. You're going to write it as a formula. And then at the end, you're going to explain to me, oh yeah, I chose option blah. Because option blah will form a precipitate. Okay? So 10-minute timer. If you need extra time, you're only allowed to get a maximum of 5 minutes extra time. So make sure you're using your time wisely. You're not wasting time. You're not talking to the person next to you. You're not sleeping. You're not on your phone. Make sure you are really focusing because I will not give you extra time beyond the 5 minute extra time. Okay? All right, I'll be quiet to give you time to pause the video. All right, awesome. So you guys are done with that. You should all be done with those questions, with all of the options. And if you did it correctly, the answer that you should get is AgNO3 plus NaCl. Because remember, this is a double displacement reaction, so it's gonna be the chlorine right here with the silver, the Ag. And silver with chlorine, it immediately precipitates because chlorine has silver as one of its exceptions. Okay? Again, I don't care about the final answer. I care about your explanation to the final answer. The fact that you try and predict the products of every single one of those reactions. Okay, which of the following compounds is insoluble in water? And I want you to get used to the terminology. So insoluble in water means that it's going to be a solid. Okay, which one of those is going to be a solid? Immediately when I saw it, my brain was like, oh yes, it's option A because carbonates generally do not dissolve in water. But then I started thinking, okay, it's bonded to potassium. Is potassium group 1 on the periodic table, maybe? Check. Check on your periodic table. So potassium is group 1. Okay. And group 1 is one of the exceptions that makes carbonates dissolve in water. So this is not going to be our option. And then we've got calcium hydroxide. And we had heard that calcium hydroxide is one of the exceptions of something that dissolves in water. So that works. Okay. طيب magnesium sulfate. Magnesium sulfate and aluminum nitrate. طبعا aluminum nitrate لا. لأنه again, anytime nitrate exists, it's like a magic weapon. Anytime nitrate exists, it makes whatever is attached to dissolve. Okay. So the only option that I have is magnesium sulfate. So I'm gonna go and check the table. Is magnesium sulfate indeed insoluble? So sulfates are naturally very soluble unless they're with calcium, barium, strontium, mercury, lead, and silver. Is that one of them? Is Mg one of them that makes it insoluble? No, which means that none of the compounds are insoluble. Okay, none of them are insoluble. Okay. Now, this is an observation question as well. I will not go through it. I want you to spend 7 minutes on this question, put it on a timer, spend 7 minutes. Now, this time, instead of me giving you the formula from the name, and this is like Unit 1 material, so I hope you guys remember it. But if you're not, like normally in the previous questions, I gave you the formula. Right now, I am not giving you the formula. So I want you to go from the name to the formula and always remember to crisscross. Always, 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 always and then do the double displacement reaction between them, and then determine solubility. Okay, so I'm gonna give you 7 minutes. Not included in them would be you taking a picture of the question in order to do it. This will not be included. So I'll give you a minute to do that, to take a picture, to prep your laptop again, and then we're gonna start the 7 minute timer. Okay? Okay. I'm gonna skip those ones because that's a lot of problems. Because this was the first time that I teach this. It was in that unit for last year's grade 11s. So that's why there's a lot of practice questions there. Now, I want to take us up a smaller level, a few extra steps, because this is the core of the solutions unit, the stoichiometry of solutions. So what are the steps saying? So it's telling us that concentration and volume of a given substance, the step one is use appropriate conversions. And we already know that. We already know that volume, liters, moles, and we also know that the unit for concentration is big M and moles per liter, right? We already know the units. We already know that in molar mass, you have to have grams. You can't have kilograms. So the next step is use the molar ratio. So normally in a solutions question, you're given the amount of one substance, and you're being asked to use the molar ratio to go to the amount of the new substance, and then do the conversions on it, whether it's dividing by volume or it's doing any form of conversion. Okay? So I'm gonna try out a question with you, and then we're gonna do lots and lots of practice on that one because it is a slightly harder concept for sure. So what is the question saying? The question is saying, determine the minimum volume of 0.42 moles per liter sodium sulfate, and they gave us the sodium sulfate. And they told us that is required to react completely with all the barium ions in 500 milliliters of a 0.100 moles barium chloride solution. So we've got a volume of 0.42 moles per liter of sodium sulfate that is required to react completely with all the barium ions. And they gave us the volume of the barium ions, and they gave us the concentration of the barium ions. This question is cut, so over here it's actually moles per liter. Over here it's moles per liter. So the question is giving me the concentration of the sodium sulfate, it's giving me the concentration of the barium chloride, and it's giving me the volume of the barium chloride, and it's asking me to solve for the volume of the sodium sulfate. That's an easier one. What do you think we're going to use in this case? If you're saying N1V1 equals N2V2, you are correct. Or sorry, C1. Why do I keep saying N? That's so weird. So C1V1 equals C2V2, and then you just plug your values in and you isolate and you solve. So this is a much simpler question. So it'd be 0.42 times 0.1, and then equals C2 times 500, and now it's just a matter of calculating C2. So what is that going to be? Oh, do you see the mistake that I just did? I'll give you a moment and try to spot the mistake that I did. Hmm. Notice the mistake that I did was that I plugged 500 instead of 0.5. So this should be 0.5. Okay. So it's going to be, because we need to convert it to liters. So that's going to be where's the calculator? That's going to be 0.42 times 0.1 divided by 0.5. That's going to be C2 is equal to 0.084. And what's the unit? It's moles per liter, which is also big M. Again, I keep reiterating that so that it sticks to your head. Anytime I'm repeating something this much, it's for it to stick in your head. The same way that I used to tell you all the time, if I'm converting from one substance to another, you guys, what do? We do the molar ratio. And the number of times I helped people with that on the exam. So anytime you see me repeating a term so many times, get the cue. Get the cue that I'm actually teaching you how to use it and how to think about it. Okay? So this is an easier question. Now let's take it up a notch. Let's take it up a notch. Now I want you to try out this question on your own. So we're gonna give you a 7 minute timer again, 7 minute timer and 28 seconds. So 7 minutes and 28 seconds where you are supposed to solve this question, even though it's slightly different, and then we will proceed. We will do it together. Okay, so you can pause the video and then I'll like you guys do the 7 minutes and 28 seconds and then come back and continue watching. Okay, so you are done. I wish if I could see who actually did it, but I hope a lot of you tried, and trying really, really matters in questions like that. So the question is saying predict the mass of precipitate expected when 1.50 liters of 0.8 moles per liter sodium carbonate, Na2CO3, is mixed with 850 milliliters of 1 mole per liter ammonium nitrate. And it's asking me for the required mass of aluminum carbonate precipitate. Okay, let's think about it. So here it looks like I have a lot of different outputs from this reaction. So I've got Na2CO3 plus aluminum nitrate, so AlNO3, now what will be the products of this reaction? Wouldn't it be NaNO3 plus Al2 bracket CO33? Now this question, it gave me the volume and the concentration, and it gave me the volume and the concentration of each of their reactants. Now the deal is, I know you guys are really gonna hate this, but the goal is I want to figure out which one of those is the limiting reagent. How do I know that? I multiply. So a couple of people asking me, Miss, okay, could we solve this by comparing the moles? The one that has fewer moles is the limiting reagent? Potentially, potentially, and that works a lot of the time, but I like to personally use mass just because I want to make sure that I'm not getting it confused with coefficients in a chemical equation. Okay, so I would personally prefer to find the limiting reagent first by doing 1.5 times 0.800 over here to get the moles. Again, remember the triangle. So this would be 0. Oh, no, not 0. It's 1.50 times 0.800. That equals 1.2 moles. And the second one right here, that's going to be equal to 0.85. And again, the unit in this case is going to be moles. Notice I converted the milliliters and the volume to liters. Again and again, I'll keep repeating. You have to have the unit liters for the volume and concentration equations. Okay, now what's the limiting reagent in this case? I'll tell you it will be the Na2CO3, but remember how we do this is that you find the molar mass of Na2CO3 and then you multiply the number of moles by it. So the molar mass of Na2CO3 is 105.99. So we are going to have 0.85 times 105.99. Wait. So I would do 0.85 times 105.99, which will equal to 90.0915. That's going to be the grams. So how many grams I have of it. So here I've got 90 grams, roughly. Obviously, on an exam, you wouldn't say roughly the way that I do. You do need to round properly, but I'm just in a hurry here. Okay, sorry, no. There's something wrong here. So this is going to be um whoops, sorry. So actually, I kind of looked at the wrong terms. So this is what's going to be 127.2. And the other one, just get it right away. So it's going to be 169.87. That's the molar mass. So it's going to be 0.85 times 169.87, which is going to be 144. So then what's the limiting reagent in this scenario? Notice the limiting reagent is actually the sodium carbonate. I have less of the sodium carbonate. So then when I do end up wanting to calculate the mass of carbonate precipitate in aluminum, so I would do 127. I think this was 127. Sorry guys, my square blocked the view. Yeah, I think it was 127 originally. So, so. This is 127.2 grams of Na2CO3, right? So I'll convert it back to moles, which is pretty much exactly the number that I originally had, which is going to be 1.2 moles. That's going to be 1.2 moles. And then over here it's going to be 0.85 moles. But then mine would be a suitable option. Wait, what did I just say? But then the Na2CO3 would be a suitable option because it is the limiting reagent. So then when you do the molar ratio, you need to balance it first before you do it. This is the problem with recording so late, guys. I think my brain's already starting to sleep. So I'm gonna balance. There's gonna be a 3 here. And then this means that there's going to be a 6 here for the sodium. And then there's going to be a 2 here to balance everything out. So the aluminum and the nitrate are already balanced. Okay. So what am I trying to find? I'm trying to find information on aluminum nitrate, on aluminum carbonate, right here. We're trying to find information on aluminum carbonate. So I'm going to use the molar ratio between sodium carbonate, which is the limiting reagent. I'm just going to circle it so we don't forget. And I'm going to convert the 1.2 moles using the molar ratio to aluminum carbonate so that then I'm able to find the mass of the aluminum carbonate precipitate. So then you're going to have the 1.2 moles ونفتكر إنه اللي تحت هو اللي عندي واللي فوق هو اللي أنا محتاجاه فأنا عندي moles of Na2CO3 so it's gonna be 3 here and in the numerator I'm just gonna have 1 so it's gonna be 1/3 so it's gonna be 1.2 times 1/3 so that's gonna be 0.4. What will my unit be? That's still gonna be moles. And then I'm just gonna multiply the moles by the molar mass to get the grams. I'm just gonna find the molar mass. Gonna be roughly 234. So that's going to be 93.6 grams. So I expect the yield from this kind of reaction when I do it in the lab, if it ends up crystallizing, I will end up with 93.6 grams of the precipitate, which is the aluminum 2 carbonate. This is one of the biggest things in chemistry, what we call crystallization. It's one of the biggest experiments that you could ever do because in it, you end up forming a solid, which is what we kind of did, but we couldn't really weigh our final product because it wasn't dried up. So if we go to the lab again and do like a double displacement reaction, I will have us dry out the output and you will see the crystals and we could weigh it and then we could compare, okay, is this what I expected to get using mathematical calculations? Or am I getting higher or am I getting lower? If I'm getting higher, then there are impurities. If I'm getting lower, then there is experimental error. Okay. Now I will leave this question for you to do as your observation. And again, I repeat, you've got your answer here. I am aware. Don't worry. I'm not dumb. But I want you to show your steps. So you will still show your steps on how you got to that answer. Do not take the shortcut and just write 0.075 because you didn't learn anything by doing so. So make sure you are actually solving. That's just for your own learning. Okay, so this is observation question 1, and this is observation question 2. And then we're going to start next class on Wednesday, actually talking about those. This is question 1, this is question 2. Now, a word to Miss Yusra, if they finished early, could they please also solve question 3? It's a much, much, much easier question. So if you guys want to just do it because it's easier, you could do so. Feel free to do so. So I'm gonna go back and I'm slowly gonna go through the different questions. So if you want to take a picture, you can do so. If you want to like pause now and do this question, all of you, and then play the video and move on to the next question, pause and all of you do it, and so on and so forth. You could also do that. So now would be the time to take a picture or to pause for the first question. And then now would be the time to take a picture for the second question, or just pause. And finally, now is the time to take a picture of the third question, or you can just pause the video and look at the screen. Alrighty, guys, I will call it a night for me before I say anything weird. Um, But I'm excited to see you tomorrow. Please continue working hard today. Please try your best. Please thank whoever is covering for me on my behalf. Make sure you thank them before you leave because they did so much work in order to be here with you guys. So make sure you're thanking them as well. And yeah, that is pretty much it for this lesson. And I'll see you tomorrow. Don't forget to submit the form. If you need to go back to view any of the other questions, just go back in the video. All right, guys, you take care. Au revoir.